This video is about continuity at a point. We are in the context of calculus, building various definitions and concepts within it. We've already discussed limits, and now we're getting to this definition of continuity, but for now, only at a point. This definition reads as follows. A function f of x is continuous at a if the limit as x approaches a of f of x equals f of a. Now, when we say continuity at a point, that can be a little confusing perhaps. If you imagine the x-axis and then a being some value on it somewhere, when we say continuity at a point, we basically mean continuity at some x value a. Sometimes the word point connotates an x and a y coordinate. Well, okay, a y coordinate would show up with a function defined at a, but in this case, when we say at a point, we're just talking about at some x value a. Now, this definition, most broadly stated as we just read, that the limit as x approaches a of f of x equals f of a, it actually could imply or does imply three different components, and these components will help us when we try to pry into examples coming up in the future here. First of all, f of a has to exist. Secondly, the limit as x approaches a of f of x has to exist. And thirdly, those first two conditions must be equal. In other words, the limit must equal the function value given at a. Now, these three different components will help us determine or be able to express in much detail why a function might not be continuous at some value a, some x value a, some point a. And so we'll be doing examples coming up when we discuss types of discontinuity, and we'll be describing the discontinuity of a function at some given x value a by listing which of these three components are violated. There are some cases where the function value exists but the limit doesn't, or the limit exists but the function doesn't, or maybe both of those exist but they're not actually equal. And so you can have various combinations of these that are violated to show that something is discontinuous. In fact, we'll also say here as a note that f of x is discontinuous at a if any of these three components are not true. This video does not contain an example discussing continuity, but an upcoming video about types of discontinuity will do some examples where we have to go back and utilize this definition and its three components to describe or discuss when discontinuity may be occurring.